Shalom to you. We're going to go over chapter 9 to prepare for the test. Okay, so it's all about circles, arcs, angles, and segments of circles. So generally remember all the parts of the circle, the diameter, which is the longest chord. Chord runs from one end of a circle to another through the center. And other chords, as the chords get away from the middle center, it gets smaller. The radius runs from the center to the side. And then, hold on. All right, so minor chord is less than 180, and major chord is more than 180, and exactly 180 will be a semicircle. And when a tangent has to be a line. A tangent is always perpendicular to the radius or diameter of a circle. And common tangents, watch what happens to the circle first. These two circles are not tangent to themselves. They are not. So when circles are not tangent, there are possibility of having two external tangents and two internal tangents. Internal means when you draw a line from the center of one circle to the other, the internal tangent will cross that line, but external tangent would not. So there's possibility of a total of 4 tangents, common tangents. But when the two circles are already tangent to themselves, they are touching at one point. So you can only have one internal tangent there and then 2 external tangents. And when the circle, they are not tangent, they are kind of overlapping, you cannot have any internal tangents. You only have 2 external tangents. When one circle is inside the other, you can only have one tangent, and it is, but all 3 of them are touching at that one point of tangency. When the circle is inside, one circle is inside the other, and they are not tangent to themselves, they are not connecting, there is no possible way of drawing a tangent to them. The same way here, whether it's no matter how close it is, as long as it's not touching it, there's no way of drawing tangent. Another thing with tangent, when you have external tangent, okay, no matter how many circles they are inside, it's perpendicular to the radius. So you're going to get similar figure. You're going to get similar figure. So there, you see that here there will be a right angle. The right angle, so it will not be given to you because you should already know that. And as long as and then these 3 triangles are congruent triangle A, D, Q, which is the largest triangle. There is a right triangle, and then triangle A, C, P is also a right triangle, the medium one, and triangle A, B, O. Okay, so and they are similar by AA, angle similarity, because each one of them has 90-degree angle. And then each one of them, you should put that here, each one of them has shear angle A. So that's why they are similar. So you can set up proportion, maybe like radius of angle 3, radius of circle 3 over radius of circle 2. The radius are corresponding parts. And all circles are always similar. So the radius of circle, the biggest circle 3 and radius of circle 2 is going to equal, if put the side 3, you have to put the whole length of AD. Okay, it's going to be AD, segment AD, over segment what? AC, something like that. Okay, so that's how to set for proportion. If you're using the small one, the same thing, AB over AD is going to equal radius 1 over radius 3, and so forth. When angles are inscribed or polygons are inscribed, it means it is inside. You're focusing on the polygon now. If we are talking about inscribed polygon, we are focusing on the polygon sharp edges. So this is a quadrilateral. It is inscribed. It is inside. So you should be able to draw an inscribed polygon. Here, the polygon is circumscribed because it is outside. It is circumscribed. Now, so when the polygon is inscribed, the circle is circumscribed. The circle is outside. When the polygon is circumscribed, the circle is inscribed, the circle is inside. So watch which particular one are you talking about. Are you talking about the circle? Are you talking about the polygon? Okay. And when quadrilateral is inscribed, when any quadrilateral, if it is a rectangle, a square, a parallelogram, a trapezoid, as long as it has 4 sides, whenever it is inscribed in a circle, that we are going to have the opposite angles as supplementary. It means they add up to be 180. So angle A plus angle C will be 180. Angle D plus angle B will be 180. And we already know that angle on a straight line is 180. So angle C plus angle E are supplementary. So if A plus C is 180 and C plus E is 180, that means A must equal E. Okay, so those stuff you remember. So let's solve a quick problem here. So you see this is inscribed quadrilateral. So how do you find x and y? How do you set up the equation to find x and y? Exactly, because x is opposite 108. So x plus 108 equals 180. So that's the first thing you set up. The same thing, y plus what? 88 would also equal 180. And then you solve the equation and then simplify it. So we do what? We subtract 108 from both sides and then we simplify. So x is going to equal 180 minus 108, which is 72. And here we subtract 88 from both sides also. So y is going to equal 92. Okay, and that's that one. So because they are supplementary, we set that up, add that up, plus 3x minus 32 equals 180. Then we collect like terms, so that's 6x. Then we add those two, minus 30 equals 180. So we can add 30 to both sides. So 6x equals what? 210. And x is 210 divided by 6. 35. And then that's not the answer, so we have to go back and substitute into each one of that. So if we substitute here, we do 3 times 35 plus 2. Okay, I think we should just multiply that and then add 2. So 3 times 35. So 35 times 3. 105 plus 2 is 107. So that's 107. And here we do the same thing. 3 times 35 and minus 32. And then you got what? What did you get?
For my answer? 73 degrees.
Okay, that's 73. All right, that's good. All right, just a quick run through of the angles and arcs. Central angle is equal to the arc that is sustained by it. Inscribed angle on the line. Whatever is inscribed, it means the vertex has to be on the circle. It's 1/2 of the arc. Internal angle that is not at the center is going to be 1/2 of the sum of the arc that are in front of it and the back of it. Outside angle is 1/2 of the arc, the two arc external out and the internal arc that is within it. So sides, when angle is from the inside, the two segments of each chord, the product of them, you multiply them and then equal the product of the other segment. When it is a secant, so you have to take the whole secant. You need to remember to take the whole secant. You have to add them up. So from there to the whole thing, you have to add that up. You add it up first, and then you multiply by the part that sticks out. Equals, you multiply this tangent by itself. Okay, and when you have two secants, you add them up and multiply by the part that sticks out, equals the length of the whole other secant times the part that sticks out. Okay, a few problems here. So we have this. What is that? What is this? AB and AC. What are they? Are they chord or secant or tangent? They are secant. So we need to, first of all, find the length of the whole secant. That's this plus x. And this is going to be 9 plus 6, the whole length. Okay, so, and then we are going to get that, if we add that up, 7 plus x, and then we multiply by the part that sticks out, which is this part, times 7. It's going to equal, if we add the other two length, 9 plus 6, and then we multiply by the part that sticks out, which is 9. Okay, that's what the theorem says. And then we simplify. 9 plus 6, it's 15, and 15 times 9, okay, 135. And here we're going to distribute because they are not like terms. So we distribute, we get 49 times 7x. Okay, so 7x. Yeah, that's what I wrote. Plus, I'm sorry. Oh, plus. Okay, so now we're going to subtract 49 from both sides. So we're going to have 7x equals
86.
Okay, 86. And then we divide by 7. Okay, it has to round to the nearest 2 decimal. So we're going to have about 12.2 decimal, approximately 29. Right?
Yeah.
Okay, good. And then the second one, so this is 12.29. And the second one asks about angle A, angle BAC. So BAC, which is the angle right here. And what type of angle is it? It's outside. So outside angle, it's always 1/2 of the difference between the two arcs that is sustained. So the larger arc is BC, which is 150, minus, which is the smaller arc, 60. So that's the 2. So 150 minus 60 is 90. And 1/2 of that 90, it's 45. So angle A is equal to 45 degrees. Okay. All right. One more. All right. So what do we know? We have to, all we have is this arc 55, but we don't know the angle 55, but we don't know the arc in front of it. We don't know the arc in front of 2x or behind it. So all we know is this arc. What can we do with this arc? We can maybe find the angle that has this arc. Which angle? Which is this arc is this angle right here. So the inscribed angle here is going to be what? 1/2 of this arc, right? So it means this angle is going to be 20. So at least start from there. It's going to be 20 degrees. And we see we have a triangle inside. See this triangle in here? There's a triangle. And the sum of angles in a triangle will always be 360. I mean 180, sorry. So if we add that 20 plus 55, and then we subtract that from 180. Okay, we're going to get the angle that is in here, which should be 105, right? So this angle here is going to be 105. And that angle 105 is vertical to 2x. See that? And so that's why we can say 2x is equal to 105 because vertical angles are congruent. So that then we divide that by 2. And then we get 52.5. Okay, yeah. All right, so again, what we did here in a shortcut is we took angle 20 plus angle 55, and then we called the leftover angle here y. They add up to be 180 because some angle in a triangle is 180. So we just added these two, get 75, bring down y, and then solve the equation, subtract 75 from both sides, and then you have 105. So this angle here is 105 because all three of them make up a triangle. And vertical angles are congruent. So we set that equal to 2x and then solve to get to 52.5. Okay, last one. All right, so you may look at these two pictures and they look alike. You think, oh, they are the same type of angle. But think this is tangent. It's not. Always look at where the vertex is. The vertex of this angle is outside the circle, but the vertex of this angle here is on the circle. It is inscribed. So you have to use different formula for that, but we need two arcs. We need the arc outside here and the arc inside, and we don't know the arc. So the first thing is finding the arc. So we're going to add arc 187 plus arc 141 and then subtract from 360 to get what is here. And it's going to be 32. Okay, so we need that, and then we're going to do the external angle is going to be 1/2. Since it's outside, we subtract the big arc minus the smaller arc. So which is 1/2 of, we subtract that, we get what? Okay, it's 109. And then 1/2 of 109 is 54 and a half, 44.5. But over here, we have x is going to be 1/2 of the arc. The arc inside that, which is this arc that is inside that, because it's on the circle. So which will simply give you 74 degrees. Okay, that's that. Study hard. Those who sow in tears will reap in joy. That's Psalm 125.